type, you can access the default table name, and you can see that the value for this is EF migration history. Now I'm also going to pass in a schema, which is going to come from my schemas static class, and I'm going to pass in the events schema. One more thing I like to configure, and this is a personal preference, so you don't have to do it if you don't want to, is configuring the naming convention for my tables inside of a Postgres database. I like to use the snake case naming convention, and this isn't available out of the box with EF Core, so we have to look for another NuGet package, and I'll go ahead and install the EF Core naming conventions NuGet package. So with this package installed, I'll go back to the events module, and there is one more method that I want to call, which is use snake case naming convention. And with this, I have configured my database context, and I can return the service collection. Now all that's left to do is to integrate the events module with our API project, and hopefully everything should work just fine. At least that's the plan, but usually things don't go as planned, so we're going to fix any errors if we run into them. So let's map the endpoints. I will call the events module static class, which has a map endpoints method, and we can pass in an iEndpoint route builder instance. Let's also configure the services by calling builder services add events module, and we're going to give it an iConfiguration instance so that it can access the connection string. As of right now, we don't have a connection string value because we also don't have a database. So what I'm going to do is to add a Docker Compose project into our solution by adding container orchestrator support. Let's go ahead and introduce a container orchestrator for Docker Compose, and this is going to create a Docker Compose project and scaffold all of the required files into our solution. If I open up the Docker Compose YAML file, let's go ahead and make a few updates here. First, I want to give a name to our container. So let's call this the Evently API. Then I'm going to configure the ports where we are going to expose our project. And I want to expose this API on the ports 5000 and 5001. So one is going to be HTTP, and the other one, or 5001 to be precise, is going to be HTTPS. Now the internal ports that I'm mapping are 8080 and 8081, and if you're wondering where these values are coming from, if we open up the Docker file inside of our API project, you will see that the Docker image that we are configuring here is exposing the ports of 8080 and 8081. Moreover, if I open up the Docker Compose override YAML file, you will see that we are passing in some environment variables for the development environment, and it's configuring the HTTP and the HTTPS ports for the Docker container. One more thing I could do is to update the Docker Compose file to use the latest version, which is 3.9, and let's leave it like this. We're mapping the internal ports to the respective external ports so that we can make our API available to the outside world. The next thing I'm going to introduce is a container for our database. I'm going to give this service a name of Evently Database. I'm also going to give it a respective container name, and the image I'm going to be running is Postgres latest. I'm configuring a few environment variables. I'm also adding a volume so that we can persist the data inside of the container locally so that we don't lose all of the data when we restart the container. And I'm exposing Postgres on the default port of 5432. If you don't want to type out all of this, you can grab it from the code snippet that's going to be right under this video. So now that we have Docker Compose configured and we have our two containers, the API and the database, it's time to introduce our connection string. So let's go back to our API project, and I will open up the app settings JSON file. Inside of this file, I'm going to add a new section that's going to contain my connection strings, and the connection string that I want to add is called database. However, I'm not going to be adding the actual connection string value inside of this file. I will be adding it in the development JSON because I want this setup to only work inside of our development environment. So let's add the value here. We're going to call this the database, and here is the connection string value, which you can also grab from a code snippet under this video. But the host is set to target the service name that I assigned to the Postgres container. The port is the internal port of Postgres, and we are creating a database called Evently. I'm assigning the username and password that I also passed in as part of my environment variables right here, and I'm setting include error details to true to get some additional information when something goes wrong with Postgres. So we're almost ready to run our application. I'm going to add a new folder inside of the API project that's going to be called extensions, and we're going to add a little helper class inside called migration extensions. This could be an internal and static class, and it's actually going to contain an extension method. I'm going to call this extension method apply migrations, and it's going to be an extension of the iApplication Builder interface. Now, before implementing this method, I need to define a small helper method, which is also going to be called apply migration, and is going to be generic, accepting a TDB context generic argument. It's also going to accept an iService scope instance. We have to make sure that the generic argument is a database context. So I'm going to say where TDB context is a DB context instance from EF Core. And then what we're going to do is to define a TDB context instance, and we're going to use the scope that we get passed in to access the service provider and get the required service of the DB context. And this is just going to be our database context type. Then we're going to grab the database context and use the database facade to call the migrate method and apply our database migrations. Inside of the actual extension method, I'm going to create a service scope first. So let's create a scope. We're going to say app application services and then create scope. And then using this scope, I can apply our migrations. So I have to specify the events DB context and pass in a scope instance. And this is how I can run some migrations when I'm running in a development environment. We're going to call this from the program file, and we will make sure that we only run this in development. So let's say app apply migrations, and this should be sufficient to run database migrations when the application starts. The only thing that's left is to actually create a database migration. Now I'm going to add a NuGet package that's going to allow me to use my package manager console, and I'm going to install the Microsoft Entity Framework Core Tools NuGet package. Let me add the latest version, and I'm going to close this up and then open up my package manager console. I'm going to target my events module project, and the startup is going to be my Evently API project. And I'm going to say add migration. Let's call this migration create database, and I will specify my context instance to events DB context. Although I don't necessarily have to do this because I only have just one database context in my solution. The output folder for the migration is going to be the database folder, and then I'm going to tell it to nest the migration inside of the migrations folder. So let's go ahead and run this. You can see that this command completed successfully. So we have our first database migration, and let's go ahead and examine what we have inside. I'm going to add an auto-generated comment on top to turn off static code analysis for this file. And inside of it, I want to examine what we have in the up method. First of all, we have a call to ensure schema, which is making sure that our schema for this module, or rather this database context, is called events. And then we have a call to create table to set up the one table that we have so far, which is also called events, and then is going to configure the other columns on this entity together with the primary key, which is the ID column. At this point, we are ready to start our application. So let me switch over to the Docker Compose project. I'm going to make one update inside of the Docker Compose project file, and that is introducing another XML value. I'm going to set the Docker Compose project name to also be called Evently. And this is just going to give me a nice name inside of my Docker desktop. So let's go ahead and start our application. If I open up Docker desktop, you're going to see the two containers that we have configured. Here is the Evently API container, and then the Postgres database that we're going to use to persist data. If I open up the Evently API, you can see that we have some commands running here, and this is our migrations executing on startup. And for example, here is the create command that's going to create the events table in the events schema. If I open up my database that's available on the localhost 5432 port, you will see that I have the events schema inside with the respective two tables. So here is the EF migration history defined in the correct schema. And then here is the events table that's currently empty, but it has all of the configured columns. If I open up the Swagger user interface that's exposed on the localhost 5001 port, you can see that we have the two endpoints or two use cases that we defined so far. They are grouped under the events tag, and if I open up the post endpoint and send the default request, you will see that the request completes and we get back an event identifier, and we can use it in the get endpoint to get back an event instance with the respective information. So this completes the very minimal setup for the events module. We have implemented two use cases or vertical slices and applied the vertical slice architecture to this module. We could continue adding more use cases following this approach and introducing other modules into the system, but I'm going to stop for a moment and refactor this to use the clean architecture because it's going to allow us to apply some interesting conventions, and I also want to move in a more domain-centric approach going forward when it comes to implementing our use cases and designing our domain entities. Which is why our next lesson is going to be refactoring to clean architecture.